We are investigating how far the point 5 comma negative 4 is from the origin. So I've already done step 1 here of plotting, plotting the point 5, 4 on the 5, negative 4, on the Cartesian plane, which is down here. And to get to that point, I really went 5 units to the right and then 4 units down. Now, before I actually show that, I'm going to draw the line segment in, joining the point 5 comma negative 4 to the actual origin, so to the 0, 0 point. So I really want the length of the line segment that I just drew in. So to get that, we're going to create a right triangle by showing the rise and the run of the line segment. So in other words, when I plotted that point, I really went 5 units to the right, and then I went 4 units down. And there's my right angle triangle. If I wanted to calculate slope, I'm looking really at a run of 5 and a rise of 4. Now that line goes up to the left or down to the right, depends on which way you're looking at it. So in the end, one of those two numbers really should be a negative number. So if I started at my point 5, negative 4, I'd be rising 4 and then running 5 to the left. So that's a possibility. Or if I start at the origin, I'm going positive 5. Let me just write that in a different color. If I started at the origin and head this direction, I'd be going positive 5, but then I would be heading downwards 4. So that would make that a negative 4. So when we talked about slope before, the slope of this particular line segment would have been rise over run, which is either positive 4 over negative 5. So this is just a little aside here. I wasn't asking you to actually calculate this, but positive rise was positive 4 over negative 5, which really is negative 4/5 overall. Or if I use the green, my slope would be rise, which is negative 4, over the run, which is positive 5. In either case, these are the same value. If you take positive 4 divided by negative 5, you're going to get negative 0.8. If I take negative 4 divided by positive 5, I still get negative 0.8. I could even write that slope as negative 4/5. Those all mean the same thing. So if you didn't know that from grade 9 or forgot that from grade 9, just be aware that those are exactly the same thing. Now, I digress a little bit. What I really want to do now is use the 4 and the negative 5, or the positive 5 and the negative 4, and use my Pythagorean theorem to help me determine the length of that line segment, because this really is my hypotenuse that I'm trying to find. So c squared would equal, if I use the red, negative 5 squared plus 4 squared. And then that would give me 25 plus 16. And if I add those together, I get 41. And that's still what c squared is equal to. So that's the length of the hypotenuse squared. But I don't want the square. I want just a c. So I have to square root both sides to get c by itself. And that's going to give me the square root of 41. That's the exact answer. That's the exact length. And when we go into university level math, for those of you planning that route as opposed to the mixed level math for grade 11, you will be expected to write things in their exact value. Okay, so the square root of 41 is the exact value, or we could say c is approximately equal. We put a dot over top the equal sign to indicate that we are rounding, and I believe that's a 6.4 to 1 decimal place, so approximately 6.4. Okay, now we're going to slide over to the next side. In general, before we do that, really what we're doing is we're taking the value of our rise, actually this is the run squared plus the rise squared. And we know if we have our 2 points, our run really is the difference in our x values. It's really like the x coordinate from point B minus the x coordinate from point A. And my rise is really my y coordinate from point B minus the y coordinate from point A. So without graphing, this is how you could potentially come up with these values. Another thing to note is that when we square a negative, we're always going to get a positive value. So it really doesn't matter whether we put the negative with the 4 or put the negative with the 5, or if we actually made both of them negatives or both of them positives. But an easy way to do this when you're working with a point and the origin, the key is it would have to be origin. Notice I have a 5 here, and I ended up using 5 in my, it ended up being the run, and I've got a -4, and that was my value of my rise when I worked with the green possibilities there. So really this c squared is really my x coordinate squared plus my y coordinate squared. Okay, flipping to the next slide. All right, let's make this a bit bigger. Here we go. To determine the distance that a point is from an origin, in general, what we are looking at doing here, I'm just getting my pen out, really our distance is based on the Pythagorean theorem. We're really taking our, let me use d for distance. Our distance squared would equal the x coordinate squared plus the y coordinate squared. And that works for when we're working with the origin. Now that's what the distance squared is equal to. If I want the distance itself, then I would have to square root both sides. And when I square root d squared, I get d. So d would equal the square root of x squared plus y squared. So for those memorizers out there, you could memorize that formula, but what I would rather you understand is really that x is just taking the x coordinate and subtracting 0. We're really finding the run value. So this piece here is the run, and this piece here really is our rise. And we're doing that because we have our Pythagorean theorem happening with wherever our point is. It doesn't really matter where the point is. It could be in any quadrant. Really, we're doing our x coordinate squared, because that's our run, plus our y coordinate squared, because this point here is at x comma y. So I'd rather you understand it than just memorize a formula, because really it makes much more sense to understand what you're doing as opposed to just memorizing. All right, use the distance formula to determine the distance each point is from the origin. So I'll walk you through the first one, and then I want you to try the next ones on your own. So my distance should equal the square root of, and this is going to work because I'm doing origin. I know that point A is 5 units to the left of the origin, so that makes my run a -5, and my rise really is -8, which means it's downwards 8. It's a fall by 8. Okay, and then we just do the calculation. -5 squared is 25. 8 squared, or -8 squared, will be 64. And I accidentally almost put an 8 there instead, 64. Add those two things together, we're going to get 89. So that is my exact answer. It's the square root of 89. If I want my approximate answer, that's approximately equal, so approximately equal to 9.4 units. Okay, so you can try the next ones, see how you get along with those. And then there's a word problem there to work through. I'll put that on the next video.